Okay, so this unit, as you can tell, the big name for this unit is what? What's the big name for this unit? This one, this word. Topic 1, which covers only what? Triangles. So the only shapes or the major shapes we're going to cover this unit is basically what are triangles. Okay, we might cover certain shapes that are related to triangles sometimes, but 99% of the time we're going to be dealing just with triangles. Okay, so the most, or not the most, one of the most special kind of triangles is called a what? It's called what? Come on, right triangle. What is the only feature of any right triangle? The only, if you actually have a geometry kit and you pull a right triangle out of it, what is so special about it, Haley? It has a 90-degree angle. A 90-degree angle. And it cannot be an approximate 90 like 89.99 or 90.001. No, it has to be a perfect 90 degrees. So you just write like this, 90. Let's use a different color. 90. What's the symbol for degree? Always. Yes, Sophia? Yeah, exactly. It's a small circle, and it has got to be what above the number, kind of like a power. It's not really a power; it's just a symbol. Okay, so it's a small circle, just like this. Okay, so one with an exact 90-degree angle. The two. Okay, what do you call two things that look like that? What's the word? When two things have a 90-degree angle, when the angle between my two hands are 90-degree, what do you call these two things, Patrick? Say again. Perpendicular. Thank you. Perpendicular. So the two perpendicular sides. So how many people know how to spell perpendicular? Again, by the way, just so you know, this is a math course, all right? So you will never lose marks for what? For spelling, okay? I will always just say, by the way, whenever I mark something for you and I circle it, it doesn't mean you lost marks. Unless it says negative -0.5 or -1 next to it, that means I took marks off. But if I just circle it, I'm just letting you know, maybe you made a small mistake that's not really worth that much to lose, okay? But pay attention to that. So perpendicular, I always misspelled it until I remember that there's a pen, P-E-N, in, it's a long word, my bad. The good news about this app is that you can squeeze the word. Oh, come on. Ta-da. Perpendicular, okay? So obviously, I don't want to keep, or we don't want to keep calling them perpendicular sides all the time. We have a shorter word, okay? It's not just me, it's actually the short word that is used in all math books. It's called the legs, okay? So the two perpendicular sides are called the legs of the right triangle. Sides are called the legs. L-E-G-S. And the reason it's called the legs is because if you actually go here right now and you take any right triangle, by the way, how many kinds of right triangles are in any geometry kit? They're very special. You cannot find any other triangles. There's this one. Hold on 1 second. And nope. 1 second. Ah, there we go. This one. Okay, so there's this one. There's this one and this one. The reason they're called legs is because if you put the 90-degree on top, it's like what? They look like what? They look like the legs of the triangle is resting on these two legs. Same here. If you put the 90-degree on top, it's like resting on these legs, though are different length. Okay. So by the way, these are the only two kinds of right triangles that exist in any geometry kit. Obviously, an infinite number of triangles exist, but the only ones you can buy are these. Okay. So the side that happens to be okay. What do you call the longest side? I know it's a different word. Some of you might not know it. Some of you might have trouble saying it. What do you call the longest side? The longest side in any right triangle. Raise your hand. The longest side in any right triangle. Hamza, go ahead. Hypotenuse. Okay. We're math people. We're not fans of big words and so on, but we have to know it at least once. Okay. So the side that happens to be the what? The longest has to be the longest. This universe will not work if it's not the longest. The longest. And also, I'll take it's right here. Can someone tell me if I hold the right triangle this way? Everyone, eyes on me. If I hold the right triangle this way, where is this side, the longest side, as far as the 90-degree is concerned? Where is it? Can someone tell me where is this side compared to this 90-degree angle? Yes, Haley? It's opposite. It's basically right in front of it or right in its face. Okay, so the longest side also happens to be opposite. By the way, opposite is just another way of saying across from. Across from. Like for example, if I stand next to Jaden, Jaden is next to me. Here, Jaden is what? Exact opposite or across from me. Perfect. Yes. These words are important because when we cover trigonometry, they mean a whole world of difference. So I just want you to put brackets here and write across from. I always want to show you as many words just in case next teacher you have in math assumes you know them. Okay. To the 90-degree angles, it's called the, Hamza, say it again, hypotenuse. Hypotenuse. Okay. So I'm just going to use a different color. H, Y, P. Let me zoom in. Hypotenuse. We're not gonna keep saying or writing hypotenuse every time. What do you think a good abbreviation or a shorthand form of it is? Anyone like to guess? Actually, many people use H. I am not a big fan of H for one reason. H could also stand for what? Height. So we need something to only stand for hypotenuse and nothing else. Does anyone remember it from maybe? But say again. Not quite. Yes, exactly. So what do you think three letters would be good to take from here? The first three, HYP. Thank you. Most math teachers and most math textbooks will actually abbreviate as what? HYP. But to Rhoda's point, some of them use just what? H. I'm a big fan of HYP. And we just call it hype from now on. So from now on, I'm just going to keep calling it hype, 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 hype. Okay? All right. So what is today's lesson? Today's lesson is one of the most important achievements of humanity, the Pythagorean theorem. If it did not exist, I'll be honest, not only this building would not be constructed, you would not actually be alive right now because a lot of the equipment that basically help you, keep healthy and be born and do things at home are based on the Pythagorean theorem. Okay, whether as building or even as programming these devices as well. Okay. So the Pythagorean theorem is the famous mathematical formula. I'm not going to use the word formula a lot. Every single time I say formula, you just think of what? Equate. Every time you hear formula, you just think equation. Okay? They have the exact same meaning. Okay? That very simply states that the what? The length of the what? What does it say? That very simply relates the length of the hypotenuse side, hype side, to the length of the. Okay, everyone, don't say perpendicular. Just say what? Perp. Every single time you read the word perp, it's short for perpendicular. Okay? So basically, the whole point of the Pythagorean theorem, is to give you two sides of the triangle, of the right triangle, of course, two sides of the triangle, and ask you for the what? Ask you for the what? I have to give you two sides, and then what's left to ask for? Come on. A triangle has how many sides by definition? Three. So I have to give you two, and I have to ask you for what? For one. So the Pythagorean theorem job is basically to help you do that. Okay. So in words, what does the theorem state? I always like to provide it in words, and then we start with the math. Never like to start with the math right away. Okay. All right, everyone. Here is the statement of the theorem. Okay. The square. The square. The square of the what? Of the hypotenuse. So let's, for one last time, write it full word. Hypotenuse. The square of the hypotenuse. The square of the hypotenuse is exactly equal to the. Can someone give me another word that means the exact same thing as addition? Like when you add two numbers or two things. I'll give you a hint. It starts with S. It's a very short word, Kareem. Sum. S-U-M. By the way, get used to this word sum. How many people know Google Sheets? Google Sheets, how many people have used? Yes, I will give you so much training in Google Sheets, especially when we do exponents and finance. And Google Sheets has what we call commands or functions. Anytime you want to add a bunch of things, use what command? Sum. You need to use, certain words. It doesn't understand the word addition. It only understands the word Kareem said, which is sum. So the sum of the what? Of the squares of the squares of the two what? Perpendicular legs. Okay, so that's the theorem in words. There you go. The square of the hypotenuse is exactly equal to the sum, addition, of the squares of the two perpendicular sides. Okay, discovered since the days of the Greeks and has not failed once to this day. If it fails, it means one of two things: either this universe doesn't make sense, or you made a mistake in your math. There's absolutely no third choice. Okay, all right. So in words, ladies and gentlemen, here it is. This is the infamous or famous Pythagorean theorem. Let me just give some space here. Give me 1 second. 1, 1, 1. Okay. All right. Now, why am I giving you? By the way, are those two equations technically the same? Yes, they are. I mean, who cares what's on each side as long as what the two sides are the same? This side has c squared on it by itself, and a squared plus b squared on this side. This side has the same thing. You just switched the side. You made the c squared here, but you still kept the a squared plus b squared here. If you say, for example, a is equal to b, it's the same as saying what? B is equal to a. Doesn't matter really which one, which variable or which symbol is on which side. Okay? So let's actually explain what each symbol means. Okay, the first one I'm going to start with is not A or B. I'm going to start with what? C. C is the most special one. Why? C is the length of the hypotenuse. So C is the length of the hypotenuse. Hypotenuse. Yes, even I have to check my spelling. Okay, length of the hypotenuse. All right. So can someone tell me what does that leave A or B to be? If C is the hypotenuse, what do you think A and B must be? Choose A to be one of the sides, which means B has just to be the what? The other side. Long, short, it doesn't really matter, okay? So A has to be what? One of the two legs. I'll put legs in quotation marks because it's the first time I guess we call sides of a shape legs just to get used to it, okay? So A must be one of the two legs, which means B, the other leg. That's it. Both of them are equal. Both of them are equal. One of them is different than the other. Who cares? The Pythagorean theorem has not failed once in thousands of years, and it should not. Okay. All right. Let me show you some. By the way, I always provide you with like websites and animations, and you know what, like things you can go and just play with and discover. So, sorry, just pencils down. So I gave you these 5 links, which are actually clickable if you open the PDF through the Google Classroom. But let's go through. Oh, my bad. This is not this one. There we go. This. Okay. So pencils down. Let's just see this. Okay. Here you have a triangle. How can you tell that that triangle is a right triangle? What's the only thing that tells you indeed that that a triangle is a right triangle? Faisal. Thank you. Exactly. There's a what? Kareem, is that what you want to say? Yes, there's a box. There's a small box at that perfect corner. By the way, just so you know, everyone, from now on in grade 11 and 12, if you see a triangle and it looks like it's a right triangle, you still cannot know for sure until you see the what? Until you see the box or the square at the corner. If I give you a triangle that does not have the square and it kind of looks like it should be, raise your hand and just ask Mr. Ramadan, did you forget to put the square in the corner? Maybe I did. Or maybe I want you to prove to me if it's a what? If it's a right triangle or not. There are ways to do that, this week. There are ways to do that next week. But in general, never believe a triangle is right unless you see this perfect corner with this perfect square. Okay, so the good news about, let's just refresh this grid, is that you can drag any of these corners right here called vertices, but we're just going to call them corners for today. Now, everyone, check this out. No matter what you do, those are people with computer science and math degrees, okay, that actually what programmed these things. So they programmed this app or this animation right here. No matter how you change the what, how you change the triangle, this angle stays at what? Which is what? 90 degrees. Thank you. So this triangle stays what? Stays a right triangle, which means this triangle still obeys the what? What's today's lesson? The what theorem? What's the name? The Pythagorean theorem. And check this out. So let's actually see if it does. So AB is the short side, right? Obviously, it has to be. It is the shortest side in the entire triangle. So AB, apparently, now focus with me here. Forget the square for now. Forget this power of 2, okay? Apparently, in this grid, the computer calculates that the length of AB in centimeters or inches or whatever is what? Is 3.614. Great, no problem. It also calculates that the what? That the length of the other perpendicular leg, which is now the long perpendicular leg, is AC, has to be, or is calculated to be, or measured to be, I should say, 11.184. And then it measured that the length of this one. By the way, what do you call this one? It's both the longest and the one opposite to the 90. So this must be the what? The pink one has to be the what? The hypotenuse. Thank you. It measured that the hypotenuse by connecting just B and C is 11.753. So far, so good. Again, we did not do that. The software did that. Check this out, everyone. So let's actually now, okay, can someone remind me again what's the statement of the Pythagorean theorem? Come on. Just the mathematical statement, not the word. Just the quick mathematical statement. There are two ways to say it. I don't really care which one. There's a reason why I give you two. Depending on the situation, we're going to use one. Haley, which one do you want to state? Sure. Okay, everyone. C squared equal A squared plus B squared. Don't write anything down. I'm just verifying things for you. We said that C is what? C by itself is the what? Is the length of the hypotenuse. Thank you. So technically, if you want to write it in words, you can say hyp squared equals, what did we say A is? Come on. One of the two sides. So I'm just going to say one side. And it still has to be what? By the way, the most common mistake in Pythagorean theorem is that people forget to what? People forget the square. And then nothing makes sense. Okay? Plus what? What should we call this side now? The what? The other side. All right. Now let's go to the math here. Let's see. What did they say the hypotenuse is equal to? They said it's what? Forget these numbers now. 11.753. Okay. 11.7. Sorry, what was it? 753. Thank you. 753 squared. Is it really equal to the addition of the other two? If it's not, I don't have a job. Really, that's as simple as this. Okay. Oh, sorry, not that. Let's say A is the short one, which is 3.614. All right, 3.614. Don't forget the square. And the other one is what? 11.184. Oops, my bad. 11.184. Okay, let's check. I'll do it right now. Here's my trusty machine. Too big. All right. Okay, all I have to do is add these up. Can you tell me if this is correct, everyone? Can you look up here? Everyone, eyes up here. Shadi, eyes up here. Okay, is this correct? 3.614 plus 11.184 equals, and then square. Sorry, is that correct? How many people say that what I just did is correct? Okay, how many people say it was incorrect? Well, I guess if it's not this one, it has to be this. Okay, who says that what I did is a complete wrong? Okay, Hamid, why? Don't tell me how I should have done it. Tell me why that was the wrong process to do. Okay, interesting. It does not give me the same answer. I could not agree with you more. You're right. But my question still is, why is the process I did incorrect? Katie? Thank you. What am I supposed to do here? Do I add and then square, or do I square each one and then add? What do you think I just did? I just did the biggest mistake when people sadly do what? I just did this, everyone. I just did this. Is that the same as the other one? No. Squaring and then adding is not the same as adding and then squaring. Completely the opposite. And you have no idea how many people sadly leave high school thinking, oh, it's the same as long as you do both processes. No, it completely destroys the math. So instead, I had to do what? I had to square each one first. So let's do that. So let's clear the memory. All right, 3.614 squared plus, that's the way it says. It says SQR, which means square this number. And then I'm going to say plus, and I'm going to put 11.184, and I'm going to square it as well. See? Perfect. Square of this guy plus square of this guy. Okay, we're ready for the number. Equals? Okay. Apparently, the addition of the two squares should give me 138.142852. Okay, how do I check that? I have got to square this side. I have to get, by the way, just so you know, I will not get exactly this number. You know why? Not because we're wrong. No, it's because even when computers measure stuff, do they perfectly 100% exactly measure, or is there still some error in it? What do you think? Yeah, if I give you a ruler right now and I ask you to measure, for example, the edge of this piece of paper, are you going to measure it perfectly, or are you going to just try your best to tell me within how many millimeters? Exactly, approximate. Guess what? Even computers have to stop at some point, like stop giving me the number at some point. Well, you know what? Let's see how close we get to that. So let's write that 138.142852. So I'm just gonna write it here. 138. What again? 142852. Okay. Let's see. By the way, if you ever see this symbol, everyone, if you ever see an equal sign with a question mark, it means I'm trying to see if the equation is true. I'm hoping it is, but I'm just checking. Okay. All right. Let's see here. What do I need to? I need to square. Clear. 11.753. We're ready? 3, 2, 1, go. Not quite. What did we get? Hold on. 138 point what? Point. Sorry. 133 0, I believe. 009. That's my point. Is it close enough? It is very close. And you know what? If my computer, if the app right here, everyone, if the app right here. Oh, my bad. Oh, it's okay. I don't remember what the numbers. Well, we can play with it until we actually get the numbers. But my point is, everyone, look. If the app gave me more digits, like more precision and accuracy, they would have been what? Exactly the same addition. Is it making sense now? Okay. Can someone tell me what would have happened if I tried to verify it without this? Do you think this is going to work? Yeah, go ahead. No way. If you don't have the squares, it's not going to give you the same answer. I'll prove it to you. No, no, no. Exactly. If you forget the squares, even if you just forget them on one side, it's never going to work. You have got to have the squares on how many things? 3. You have to have it on top of the A, on top of the B, and on top of the C. If you do this, okay, we don't even need to even do it by calculator. So can someone tell me what's 3 plus 11? Seriously, what's 3 plus 11? 14. And obviously, this decimal plus this decimal will make it more than 14. It's already what? Not equal to that. So if you ever think that the Pythagorean theorem is C equals A plus B, you are completely off. It's what? It's C squared equals A squared Thank you, plus b squared. Perfect. Okay. So that's one way to see it. Okay, here's another way. Okay, everyone. Oh, sorry, my bad. Actually, this maybe this one is. Ah, yes. Everyone, pencils down. Look at this one. This is actually the reason that since the day of the Greeks, the Pythagorean theorem was invented. They wanted to actually collect taxes on pieces of land. They wanted to collect taxes and pieces of land, and they discovered that when there are like two streets that have what degree between them? 90 degrees, okay? That the piece of land in here, that's basically the perfect square bounded by this street, and this piece of land bounded by the other square. If you add this piece of land to this piece of land, they exactly give you this piece of land. That's another way to what? That's another way to understand the Pythagorean theorem. And the reason is that, does anyone know what's the area of any? Hey, Brian, just a quick question here. Let's go new. Can someone tell me what shape is this? No tricks. What shape is this? Rectangle. Does anyone know what's the area of a rectangle? Area. Like if I want to know how much paint I need to paint this, how would I know the area of any rectangle? It's one of the most basic geometry formulas you learn maybe in grade 5 or 6. Patrick, say again. Base. Okay, so there are so many ways to say it. You said base times height. Does anyone have another way of saying it? Kareem? Length times width. Length times width. So it's interesting. Basically, if I know the length, and this is the width. Okay, how about this shape now? Everyone? How about, to the best of my ability, I guess? How about this shape? What do you think I wanted to sketch? What's the most perfect rectangle? If it's not a rectangle, it has to look like a what? What do you call this? A square. What's the area of a square? It's still what? Length times. But what's so special about a square? Both the length and the width are the what? Are the exact same. Which means really the area, if you've never thought about area of square, any square in the universe is equal to what? It's equal to length times what? Width. But the length and the width are the what? Exactly. Thank you. What do you do when you multiply? What's x times x? Does anyone remember? X squared. Thank you. Length squared. Why do you think we're relating it to the area? Because of this. That's what they actually discovered 5,000 years ago, is that the areas add up to be the same. Okay, so let's, everyone look. Here's the app, and it's showing you the side length. Apparently, everyone, look up here. This length, only this length, is apparently 2.75 centimeters. Okay, whatever. I'm going to trust the computer. B is 6.39 centimeters. Okay, a squared plus b squared, which is this squared first plus this squared second, is going to give you a total of 48.33. C is 6.95. Guess what? If you square C, you'll also get the exact same answer, which is basically telling you that the areas add up to the same thing. Square 1, which is the green one, has an area of 7.56. Length times width. Square 2 has an area of 47.7. Length times width. Square 3 has an area, this guy, of 48.33. If you add the small square to the small square, you get the exact same thing. So that's another way to think of the what? Of the Pythagorean theorem. The Pythagorean theorem tells you that if you have a square here and a square here based on these two lengths, they are both combined, not each one, no, combined as big as this total one. Okay? My last app I want to show you is this guy. Here. Everyone look. I like this app because this one shows you, everyone, just pencils down, look at this one. This one shows you that if you don't get the angle to be exactly how much? 90 degrees, your areas are not going to add perfectly to be what? Small plus small equals big. I'll show you an example. Does anyone, I don't know if you can I zoom in? Let me see. Yeah, oh, perfect, okay. Do I have a 90-degree angle there? Can anyone see it? But the answer could be yes, could be no. Do you see a 90-degree there? No. This angle is 45.48, 74, 60.52. I have to make one of them what? To apply today's lesson. I have to make one of them what? 90-degree. Okay, I'll try to drag some side. Maybe this one is the closest, so I just need to open this up a little bit. All right, let's open it up. Okay, okay. I'm gonna try my best to make it 90, maybe, or as close. Wow. Actually, this is my first time ever. I usually get like 89.95 or 90.01 or something. Okay. All right. So apparently here, this is 90 degrees, which means definitely now, if I add this guy to this guy, what do I get? What must I get for sure? If I add this square to this square, what should I get? I should get this one absolutely. Well, let's check and see. 20. What was the 5.97? So remember with me, 5.97 plus. What's the next one? 21, 25. 21, 25. 2722. Come on, go away. Here's my question. I'm gonna screw this up a little bit. How can you screw this up? What do you do with the triangle? Come on, we fixed it by making an angle 90. So how could you screw it up? But exactly, by changing it to anything but 90. You know what? I'll make it 91. I'll try to make it 91. No way, man. No way. Remember, 90 is the only way to make the numbers work 100% correctly. Anything off will mean you're close, but not quite there. I'll prove it to you. We added this one to this one, and we got this one, right? Okay. Well, now let's add this one to this one. I guarantee you, you're not gonna get what? You're not gonna get this one. Let's check. Here it is. What's the area of the small one? Still 597 because I didn't change it much. Actually, I didn't change it a lot. 5.97 plus what? This guy is 23.55 plus 20. Sorry, was it 23.55? 29.52. 29.88. But is it close enough? But it's not the same. You know why? Because I slightly what? I slightly messed with the what? With the triangle. Exactly. Is it making sense now? The Pythagorean theorem only works 100% perfectly if one angle is exactly what? 90 degrees. Anything else less or more, you're close, but you cannot claim it's what? It's Pythagorean theorem. That's basically the point of today's lesson. Yes. Sure. Okay. All right. So now let's actually do what? Let's actually do the examples. Okay, everyone, let's go back to the notes. Come on. Why did I give you two when I mentioned it to Haley that there are two statements she could provide either one? Why did I even give you two? Why did I give you c squared equals a squared plus b squared and a squared plus b squared equals c squared? Because depending on which side you're trying to find, there's an easier one to use. Okay, so everyone, listen to me very carefully here. Let's look at all of these ones. Look at all of these examples. By the way, I'm gonna do two, and your homework is to do the other two, which you can always check, at like after the school day is done, if to see if you got it right or wrong. Can someone tell me what's the only side that's missing from each one of those triangles? You can call it C. What's the name for that? Hypotenuse. Thank you. By the way, just so you know, everyone, listen up. If I give you a problem, listen up. If I give you a problem on the quiz or a test or something, I am never gonna tell you that this length is called what? No, a point of me testing how well you know the Pythagorean theorem is to see if you can what? Label. Get used to this word, everyone. Label. What does label mean? In English. You don't even forget math. What does label mean? Say again? Not quite. When you label something, what does that mean? When you put a label on something, what does that mean? Name it. Thank you. Call it something. I cannot call them A, B, C for you. If I did, it's kind of like, doing, it's kind of like, oh, I'm telling you which side is which. You have got to label properly from the get-go. Well, you know what? Today we take it easy. So if they label those C's, that means all of these are what? All of these are hypotenuses, okay? Can someone tell me what it means to find something to the nearest tenth? By the way, everyone, we're doing math here, and we're going to get a lot of decimals. So rounding is a very important skill to have. Who understands what nearest, by the way, you're going to hear nearest tenth, nearest hundredth, nearest thousandth. What does nearest tenth mean? Patrick? Around your answer to how many decimal places? One. You're only allowed to show one decimal number or decimal digit after the point or after the decimal point. Okay. So I want you to write nearest tenth means one, sorry, one decimal. Great. All right. So can someone tell? Yes, Hamza, go ahead. Sorry. No, go ahead, please. Yes. No. So, okay. So here's the thing. The tenths are what? 10%, which is what? 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. Hundredths is what? 0.01. Basically, you judge by how many zeros in the word. How many zeros in 10? One. So you round to one decimal place. How many zeros in 1,000? Three. So you round. So if you say near 1,000, you round to what? Three. You're only allowed to show exactly what? Three digits after the decimal point. Make sense? That's why. All right. Question, everyone. What side am I trying? Am I trying to find in all of these? C. When you're trying to find what? Which is what? When you're trying to find C, start with the equation that starts with what? Why? Because it's already on which side of the equal sign? Right or left side? Left side. It's already where it belongs. Do you see what I mean? You always want, not always, but it's good to it's good to have the variable or the symbol or the unknown or the layer that you're trying to find on the left side. It's not a deal breaker if it's on the right side. That's fine. But you know what? If it's there, why not use it? All right. So let's start. So the first thing you write is the equation. Please always, everyone, when you're writing your solution steps, please always show me the equation. A couple of things. Number one, you get part marks because you tell me I know at least what to use. And at least you tell yourself where the numbers go. So c squared equals a squared plus b squared. That's a plus. Okay. What did we say about the a and the b? Come on. What did we say they represent or they stand for? Legs. Does it matter which one is called A, which one is called C? Sorry, which one is A, which one is B? No. The only one that you always need to, by the way, half of you might call this one A or might label this one A, and half of you might label this one A. That's fine. But all of you have to agree on what? C is the only one that everyone has to pick right or to pick the same way. So you know what? Randomly, I guess, I'm going to choose green because we know these. I'm going to call A here and B here. I know, by the way, it seems like I'm always choosing A to be the short one. It's a complete coincidence. All right, let's start. Can someone tell me what should I do next in that equation? Which values do I know? The C, the A, or the B? No, which ones do I know? C, A, or B? I know the A and B. If you know something in math, plug it in. Write it down. So this means C squared equals, now what's the A? It's 3.2. Oh, by the way, how many people had math teachers always make them put the units inside of the calculation? Please don't do that. Okay? I am a big fan of what? I'm a big fan of you remembering that your final answer needs a what? Needs a what? Needs a unit. Only your final answer. Middle steps, please be quick, be efficient. Okay? I will not penalize you or think of you less in any way. So 3.2 squared plus what? What's the other one? 3.7 squared. And let me squeeze this a little bit. Sorry? No, no. I just no, no. Do not bother putting units like centimeters or meters in. Honestly, it just it clutters up the space, and you just have to write too much. No, just remember to put it where, Hamza? At the what? At the end. Final answers in math, 99% of the time need a unit. Okay, let's keep going. C squared. Oops, sorry. C squared equals. What's the square of 3.2? I know this one. 10.24. It's a famous number, so I know it. How about the square of 3.7? 3.7 square, not square root, square. 13.69. Okay. I'm almost done. What do I do now? C squared is equal to what? Add this guy to this guy. Well, 10 plus 23, so I mean 10 plus 13 is 23, and 24 plus 70 is 93. And we're done. That's it. So apparently, the length of this guy, the length of this from here to here, sorry, it should be straight, is how much? Is 23.93. Jaden? Yeah, yeah, go, go. Thank you. Is this my final answer? No way. I was just tricking you. Jaden, what process should I do just to finish off? What's the opposite of squaring? Square, square rooting. So let's square root this one. Let's square root. Yes. Sorry, say again. You did not square root. You divided by 2, my friend. Yes. But I can guarantee you the square root of 23 is not 11. It's 4 point something, right? Exactly. The only way, Muhammad, again, these are the common mistakes, and I'm so glad that people make them. Make them now so you don't make them after. You said 11 point what? I can guarantee you that 11.9 happens to be half of this guy. You see what I mean? Remember, square rooting is not like dividing by 2. They're not the same, right? Okay, question everyone. What's the square root of 16? Come on, 16. What's the square root of 16? How can you prove it? 4 times 4 gives you back what? What's half of 16? 8. Do you see the difference? Half is just when you double it. Doubling and squaring are not the same. Sadly, many people think it is. So the final answer is C equals square root of 23. 93 is equal to, Haley, you said it? 4 point? Okay, so 4.98, right? Oh, sorry, 89. But the question is very specific. It wants you to round, Hamza, to how many decimal places? 1. You cannot show none. You cannot just say 4. You cannot even say what? By the way, 4.89 is very close to what? Very close to what? 5. But 5 is not what? Is not a number with a decimal. It's what we call a whole number or a full integer. I need to show 1. Yes? So 4.89, how do you round? You cut the number right here. Who remembers the rounding rules? There's only one rule for rounding. How do you decide if it changes or not? Manal, say again. 0. So, sorry, you said more than, oh, actually 5 or more does include. So everyone, 5, 6, 7, 8, 9 after the line. If the number here, so I should say digit. If the digit here is 5, 6, 7, 8, or 9, what happens to this number? Changes by how much? 1. Down or up? Exactly. What if the digit here is 0, 1, 2, or 3? Sorry, 0, 1, 2, 3, or 4. This one is completely what? Left alone and not affected. Yeah, 5, 6, 7, 8, 9, you change. So 4.9. What's the unit here? Apparently, this triangle is measured in what unit? Inches. So you just write IN. Full marks. That's it. Okay. Okay. Since all of these are the same, well, the same process, I should say. I'm just gonna do a random other one. I'm gonna do this one. Everyone, I'm gonna do this one, and those two are homework. So homework, homework. Everyone. By the way, I know. Okay, what does km stand mean? Kilometer. In again. Inches. AU. This was taken from a practice worksheet on some website. Don't worry about AU. Please go ahead, scratch it. Okay, you don't know this. AU stands for atomic unit, like very, very small distance unit. Don't worry about that. Okay, everyone, go ahead. And so here's my question to you. If a question does not have units, do you have to have units in your final answer? Nope. If this one was just 3.2 and 3.7, then your final answer is as good as it is with just 4.9 and you call it a day. Okay? So don't put units where no need to put them. All right. So let's do this one. Okay? So same thing. I guess I'm going to make this one A now and this one B. Which one am I trying to find? Come on. C. So we start exactly the same amount of work. Let's do this. So C squared equal A squared plus B squared. Okay, I know this one. I know this one. So C squared equals I guess A is 12.9. Don't forget the square plus 7.5 with a square. All right, C squared. Can someone give me 12.9 squared, please? I know 7.5. 7.5 is 56.25. Sorry, say again. I think you square rooted. Because remember, 12.9 times itself is going to be a big number. It's almost like 160 something. You square rooted. That's how you got 3. Let's hear it twice, everyone. Who's got the square, not the square root, square of 12.9? Once I know it's very close to 169. Yes, 166 for 1. Thank you. Perfect. All right. Let's add these up. I'm gonna zoom in so everyone can clearly see. Mr. Smilovich, all good? Okay. Um. So 166 plus 56 is 200. 6 and 5 is 2. 2 point what? 41 and 25 is 66. Is that correct? Can someone check? Has to be correct. I mean, 25 and 41 is 66, and 6 plus 6 is 2. You carry the 1. Well, yep. So is that my final answer? No way. And by the way, it doesn't make sense. If I give you right now, everyone, just so if I give you a stick that has a length of 12.9 centimeters and another stick that's got a length of 7.5, and I ask you to connect them with the third stick, there's no way this connection is as long as 222. Way too big. Like the answer has to make sense. Math is the universe. If it doesn't make sense, it's incorrect. So C is what? The square root of this guy. So which is what? My guess is 14 point something. Yes, 14 point. And again, you actually give me 2 digits. I always like to practice rounding with you. So before rounding, it's 14.92. All right. And how many digits am I allowed to show? 1. So I have to cut here. What happens to the 9? Something or nothing? Nothing. 2 is a part of the low end, so it does not change it. So the final answer is 14.9. And what's the unit? Thank you. By the way, in your written part, in your written work, you never have to show me the rounding step. If you just jump from here, if you jump, I don't like this error. If you jump, if you just write this, I'll understand that you understand rounding and you did it behind the scenes. Okay, very good. Okay, one more, everyone. One more, because that's gotta be the last one for today.